Hi, thanks for joining me in the second part of the where we make use of sriov device plugin and also MACVLAN for the 5G core deployment. So to give a rundown overview of what we discussed, so this is still our architecture, and I've tried to do a brief rundown of the Helm chart, and these are the IP addresses for all the interfaces. So the G node B to the UE remains the .1, and then the N2.2 and all the like till the only addition we are putting here is the internet, right? So we are simulating the internet and also putting VPP as the gateway for terminating the IP traffic. So let's go quickly into the deploying it via Helm. So we see here that if we check our namespace, we see it's empty. So let's go ahead to do the Helm install. It's just your usual Helm install. There is no special commands here. So I'm using this namespace, doing an upgrade and adding the dash install in case it's not installed. And then this is the name of the release, where the Helm chart is, and then if the namespace does not exist, then if this namespace does not exist, then it's going to create it. So we wait, and then we'll make use of, like I said, K9S. So if we, I'll be using three shells so that we'll be able to going into the one. We'll use this for the VPP, and we'll use this for the external test node, and then we will use this for the UE. So once the UE is up, then we'll open a shell instance into it, and then we'll also exec into the VPP also, and then see how the traffic flows. So one other thing I did not explain in the previous videos is you can see that even though I'm using the web UI, I'm not adding the UE via the web UI. We're actually using a Kubernetes job for that. So let me confirm if it's a Kubernetes job or a pod. So the purpose of let me see. So okay, so I'm running it as a deployment. The reason for that is that if we still need to do some additional O&M operation, O&M steps. So what this UE import is just doing is it's instead of opening a web UI and then clicking all the likes, it's going to add the user in the MongoDB database. And if you recollect the flow for Open5GS, the UDR and the PCF and of course the web UI also, they are making use of the MongoDB as the database. So you using this, it's a bit faster. If it's repeatable, you could it's like you just calling the APIs in your normal telco stuff to add the subscribers. Okay, so that's why we are doing that. So, but while this is while the pods are coming up, so if we see what we are doing here, we are first of all creating the default username and password for Open5GS. That's the purpose of this line, and then we are copying this the actual script, which is provided by the Open5GS project also. Then we are making it executable, and then we are running a one-time script to create the subscribers in the MongoDB. If we take note of this, we can see the let's see. Trying to see where I created the script itself. So this will be the Open5GS script, the database CL script. So let's scroll up a bit. Yeah, that's it. So yeah, okay, so it's this. So this is the script I'm actually using to create just one user, right? So you see here we are running the MongoDB, and then we are adding the DB subscriber update. And you see here we have the IMSI, which we are picking up from our mvalues.yaml file. All this everything here is being picked from the values.yaml file, and it's the first script, like I said, that will get run. And once it's run, then it goes to just sleep indefinitely, so that we can log into it and do more sessions. So okay, so we have our pods up and running. So now the first thing we need to see, let's go to our UE and check the logs and see if we, yeah, so all right, we have a UE session here. I mean, we have a PDU session. So that means that the attach was successful. So let's open the shell here. Then, yeah, let's move into the UPF, I mean the VPP. So this is the VPP. So to go into the VPP shell, we do the VPP-ctl and quickly do some checks also. So this is the show interface. So like I said, this is the interface to the UPF-N6. This is the interface to the external test node, and this is to the internet. All right. Then if you want to see just the address alone, you can do show int address. So you see here 7.1, 6.2, 100.254. Yeah, let's go to the external. So if we check the IP address here, we see that it's 7.2, and the one for the VPP is 7.1. So we see 7.1 is the interface for the VPP here, and this one is 7.2. Then this will be the N6 leg. You see that the VPP will be 6.2 while the UPF will be 6.1. So now I want to ping the 7.2, which is the test node from the UE. So what we do there is, first of all, let's just do a TCP dump. Then we can say, so the traffic will come from the EXT, the external interface, and then we could put the IP address of the that's the IP address of the UE that was that the SMF allocated to it. So we're running, and if everything works fine, if we ping this IP here from the UE, then we should see the IP address of the just of the UE, not 7.1, which is the interface IP of the VPP. So here we could add a trace had AF. That AF is the kernel interface, kernel driver interface. So we put AF packet input. Let's just do this, and then let's do a ping from the UE. So we'll source the ping from here, and then we'll do 192.168.7.2. Then let's just make it a 4. Yeah, so the first 4 pings, of course, will, because of the ARP entries, is going to that's why you have the initial packet logs. So here we see that we're actually seeing the UE IP. First of all, let's quickly do the show the trace here also. We can neglect this, not this. These are interesting to us. So let's see if we can see the traffic of the UE. Are we seeing it here? We support. I didn't check this before the. So let's do this. Let's do a clear trace. Just want to show us that the traffic is actually passing through the VPP also. So let's do the 10 pings. So if we do this flow trace, okay, yeah. So yeah, we nearly missed it. So we see this is the traffic. You see all the way here. We see how the traffic is flowing via the VPP. So here we can see, like I said, you have the UE traffic, right? 10.45.0.2, and it's going to the external interface. And here it's showing you the ICMP packet, it's showing you how it's doing the switching and all the like. You can see that this traffic is not destined for the VPP. All right, so that's just to show us that it's not currently doing the NAT. So like I've shown here also, the UEIP pool, the UEIP is the one that is showing, and it's not using the NAT functionality. But this will change once we ping an interface, something on the internet, right? So like 4.4. So let me quickly pick this snapshot so that it will, you can save it for the Git repo. So let's see. So that here, so I come here. So okay. So let's do a clear again. Let's clear the trace. Okay. Now let's set the trace back up. But let me quickly set this to make it easier. Okay, so I've left the packet running on the external test node also, and then this is the VPP. So let's do the hard again, and then let's quickly do this. So here we see that we can reach the internet, but then you can see that the external node is not getting that traffic because it's not going through that. So, but if we do the show trace on VPP, then we should see something about the NAT. Yeah, so you can see here, these are the interesting aspect of the NAT. So here you see, okay, so actually this is the return traffic. So because we are saying input, right? So we see that the 4.2.2 is, you can see that, let's move up here. Yeah, so yeah, we see that 10.45.0.2 is going to 4.2.2, which is the internet. This is our UEIP. So if you look at it here, you can see here that the NAT entries are now showing up, right? So we see here that it's changing it to, it's switching it. Now you can see it's doing a rewrite here, and it's rewriting it to the 100.254, which is the interface IP here. So the one I specified here. So it's doing a source NAT to this, and then before it goes to the internet. So you see here that the actual IP, the IP has been NATed to this, and then it's going to the internet. So this shows you that the traffic is indeed being NATed and is passing through the VPP. So let's capture this also, and then this is actually the return traffic. So we see here that it will do a reverse route back to to the UEIP pool. So to the UEIP address. So here you see this is coming for 4.2.2 to what? To 100. 100.254, and then you see that it's doing is there is a match because it has an entry for that NAT traffic. All right, so it's doing a switch back. You can see the 10.45.02 will be the will be changed. It will do a rewrite here. You can see it's doing a rewrite, and then it's changing it all the way back to the UAI people. So this is also an interesting traffic. So let's I'll just pick this up also, and then so as to show put it also in the so that's about it concerning this this demo. So if you want to try this on your lab, take note, you can just do it, follow the traffic flow and update the point, the IPs, or how you configure your sriov, or how you do your MACVLAN, which might be definitely different from how you have your own. So that's why I didn't do much work on the Proxmox side, because the hypervisor, there are different kinds of hypervisor that people tend to use. So, but the main issue is to get the flow of the traffic. So that will be all for now. And thanks for watching. And don't forget to give us a like and then subscribe, and also share for others to be able to partake also. Thank you.